September 17, 1944, Hürtgen Forest, Western Germany. Major Ingrid Kellner pressed her trembling fingers against the leather-bound combat journal as she wrote observations that would have earned her immediate court-martial if discovered by Gestapo investigators. The American Shermans are no longer the prey we have hunted for 2 years. Something has transformed these machines into predators that stalk our finest panthers, and we cannot comprehend what evil genius has unleashed this terror upon us. Through the dense canopy of the German forest, Kellner had witnessed an engagement that shattered every principle of armored warfare she had learned at the Panzer Training Academy in Wünsdorf. 9 Panther Ausf G tanks from her own 21st Panzer Regiment, each mounting the devastating 7.5 centimeter Qua-K 42L/70 gun behind 100 millimeters of Krupp steel armor, had encountered 14 seemingly standard M4 Sherman tanks advancing through the forest clearings near the village of Bergstein. In 23 minutes of combat that defied comprehension, 7 Panthers burned like funeral pyres while the American Shermans pressed forward without losing a single vehicle. Kellner, one of only 3 female tank commanders in the Wehrmacht, had survived every major engagement from Kursk to Normandy. She understood tank warfare better than most men in the German army. What she had witnessed this morning violated every law of armored combat she knew. The mystery deepens. For 16 months since the Allied invasion of Sicily, German panzer crews had operated under clear tactical assumptions. The American M4 Sherman, despite its reliability and numerical superiority, remained fundamentally inferior to German medium and heavy tanks. The standard Sherman's 75mm M3L/40 gun could barely scratch the paint on a Panther's frontal glacis at combat ranges, while even the improved 76mm variants struggled to achieve reliable penetration beyond 500 meters. Wehrmacht tank gunnery manuals explicitly stated the engagement parameters. 1 Panther could engage 3 Shermans at 1,000 meters with virtual certainty of victory. 1 Tiger could destroy an entire Sherman platoon before sustaining meaningful damage. These calculations had proven accurate in thousands of engagements across North Africa, Italy, and Western Europe. Yet something fundamental had shifted in the American armored formations striking into the German heartland during the autumn of 1944. Reports flooded into Army Group B headquarters from panzer commanders across the Western Front, each describing encounters with Sherman tanks that behaved in ways that seemed to violate the basic physics of tank warfare. Oberstleutnant Helena Richter, commanding the 116th Panzer Division's intelligence section, compiled these reports with growing alarm. At her headquarters in a commandeered brewery outside Düren, Richter spread dozens of after-action reports across oak tables that still smelled of hops and grain. The pattern emerged like a nightmare taking shape in daylight. Hauptmann Fischer reports his Panthers engaged at optimum range, 800 meters, and were destroyed before achieving a single hit, Richter noted in her intelligence summary to General Bergstein. Major Kruger describes Sherman tanks achieving first-round kills at 1,200 meters against our most experienced crews. Oberleutnant Weber witnessed a single American tank destroy 5 Panthers in succession, each shot a killing blow through the turret front. The reports described American tanks that looked identical to the standard M4 Shermans German crews had been fighting successfully for years. Same sloped frontal armor, same general proportions, same distinctive profile that German tank recognition manuals had taught every Panzer crewman to identify at distances exceeding 2,000 meters. Yet these seemingly familiar adversaries possessed a lethality that transformed them from predictable opponents into apex predators. Dr. Elisabeth Hoffmann, the Wehrmacht's leading expert on Allied tank development, received an urgent summons to Army Group B headquarters on September 20th. Hoffmann, who held a doctorate in mechanical engineering from the Technical University of Berlin, had spent 3 years analyzing captured Allied equipment for the Wehrmacht's Technical Intelligence Division. "The Americans have achieved something we did not believe possible," Hoffmann reported to the assembled staff officers. "These are not simply improved Shermans with better ammunition. Our ballistics experts have examined the penetration patterns on destroyed Panthers. The energy transfer characteristics indicate a completely new class of tank gun, potentially exceeding the performance of our own 7.5 centimeter Qua K42 L/70. The revelation unveiled. What German intelligence could not fathom, what would remain classified by the United States Army until 1967, was that they faced the M4A3E8 Sherman Easy 8, equipped with the revolutionary M1A2 76mm hypervelocity gun system and the top-secret T13E1 integrated fire complex system. The program originated in February 1944 at the Aberdeen Proving Ground in Maryland. Conceived by Colonel Sarah Morrison, the first female graduate of the Massachusetts Institute of Technology's Mechanical Engineering program, and arguably the most brilliant ballistics expert in the United States Army. Morrison's revolutionary approach to the Sherman problem emerged not from increasing armor thickness, which would compromise the tank's crucial mobility advantages, but from creating a weapons system that could destroy any German tank at ranges previously thought impossible for mobile artillery.
British. The M1A2 gun represented the first breakthrough. This weapon featured a revolutionary 55 caliber barrel, constructed from specially treated chrome molybdenum steel that could withstand chamber pressures exceeding 50,000 pounds per square inch, nearly double that of conventional tank guns. The ammunition system employed tungsten carbide penetrator cores surrounded by aluminum sabots, creating projectiles that maintained lethal velocity beyond 1,800 meters. But the gun system was merely the foundation. The second breakthrough was the T13E1 fire control computer, a miniaturized version of the mechanical calculators used in naval gun directors, adapted for the cramped confines of a tank turret. This analog computer automatically calculated range, target movement, ammunition ballistics, and atmospheric conditions to provide firing solutions accurate to within 2 meters at maximum effective range. The third breakthrough was perhaps the most ingenious. The M12A1 stereoscopic rangefinder integrated with the gunner's primary sight. Using split-image technology borrowed from precision surveying instruments, this system allowed American gunners to determine target range with an accuracy that German crews, relying on visual estimation and experience, simply could not match. Historical context and development. The genesis of Project Thunderbolt traced back to a series of catastrophic tank engagements in Italy during the winter of 1943-44. The 1st Armored Division had lost 47 Sherman tanks to German Panthers and Tigers in a single week near Monte Battaglia, with American crews achieving only 3 confirmed kills in return. General Omar Bradley, witnessing the aftermath of these one-sided engagements, sent a classified memorandum to Army Chief of Staff George Marshall. "Our tank crews are being slaughtered by German armor that outranges and outguns them by factors we cannot overcome through tactics alone. We require immediate technological intervention, or we must accept unacceptable casualty rates in any future armored operations." The response came from an unexpected source. Dr. Vannevar Bush, director of the Office of Scientific Research and Development, recommended Colonel Sarah Morrison for the task. Morrison had already distinguished herself by designing the proximity fuse systems that revolutionized anti-aircraft warfare, and her theoretical work on high-velocity ballistics had impressed even German scientists before the war. Morrison's initial assessment was brutally honest. The Sherman tank, as currently configured, cannot engage German heavy armor under conditions that provide reasonable crew survival probability. However, the Sherman's mechanical reliability, ease of production, and logistical footprint make it irreplaceable in American strategy. The solution is not a new tank, but a new weapons system. Working with a team that included Dr. Margaret Chen, a ballistics specialist from MIT, and Captain Ruth Williams, a mechanical engineer from General Motors, Morrison approached the problem with systematic precision. They analyzed every aspect of tank versus tank combat: target acquisition, range estimation, ballistic computation, and ammunition performance. The breakthrough came when Morrison realized that German tank crews relied heavily on visual range estimation and manual ballistic calculations. German training emphasized aggressive tactics and crew expertise over technological aids. American crews, with less extensive training time, required technological solutions to achieve comparable effectiveness. We cannot train American tank crews to the level of German veterans. Instead, we must give them tools that make expert-level performance achievable by average soldiers in average conditions. Technical mastery. The M4A3E8 Thunderbolt Sherman maintained visual similarity to standard Sherman tanks through deliberate design choices. German tank identification relied on silhouette recognition, and maintaining the familiar Sherman profile ensured that enemy crews would underestimate the threat until engagement commenced. The M1A2 gun system featured several revolutionary characteristics that distinguished it from any tank weapon previously deployed. The 76mm bore diameter, while appearing modest compared to German 88mm guns, achieved superior performance through advanced metallurgy and ammunition design. The chrome molybdenum steel barrel, heat-treated using techniques developed for aircraft engine components, could withstand sustained firing without accuracy degradation. The hypervelocity ammunition represented a quantum leap in tank-killing capability. Standard HVAP-T rounds featured tungsten carbide cores weighing 7.2 kilograms surrounded by aluminum sabots, which separated after leaving the barrel. These projectiles achieved muzzle velocities of 1,036 meters per second, nearly 40% faster than the German 7.5cm WKK-42 L70 gun firing standard ammunition. The ballistic performance was devastating. At 1,000 meters, the M1A2 gun could penetrate 180 millimeters of homogeneous armor at 30 degrees, sufficient to defeat the frontal armor of any German tank in service. At maximum effective range of 1,800 meters, penetration remained above 140 millimeters, still adequate to destroy Panthers through the turret front or side armor. The T-13E1 fire control system represented the most sophisticated mechanical calculator ever installed in a combat vehicle. This analog computer, weighing only 23 kilograms, processed 17 variables to provide firing solutions: target range, target angular velocity, own vehicle movement, barrel temperature, ammunition temperature, atmospheric pressure, humidity, wind velocity, cant angle, gun elevation, traverse rate, range rate, super elevation, drift correction, and Magnus effect.
The system operated through a complex arrangement of cams, gears, and differential mechanisms that performed calculations faster than human crews could execute manual computations. Input from the M12A1 rangefinder automatically updated range data, while gyroscopic sensors detected vehicle movement and target tracking rates. The gunner's interface was elegantly simple. The improved M71D telescopic sight displayed target imagery overlaid with a dynamic reticle that automatically adjusted for range and lead angle. A small digital display showed precise range to target and recommended aim point corrections. Firing accuracy at maximum range exceeded 75%, compared to approximately 20% for German crews using manual methods. Early encounters and first blood. The first operational Thunderbolt Shermans reached the European theater on August 15, 1944, transported aboard the Liberty ship SS Margaret Fuller under extraordinary security measures. Only 18 tanks initially assigned to Company A, 32nd Armored Regiment, 3rd Armored Division. The selection of crews for these revolutionary machines followed strict criteria established by Morrison's team. Tank commanders required demonstrated combat experience, above-average mechanical aptitude, and educational backgrounds that suggested ability to master the sophisticated fire control systems. Gunners needed exceptional eyesight, steady hands, and high scores on mathematical comprehension tests. Star Sergeant Dorothy Coleman, a former schoolteacher from Ohio with 18 months of combat experience, commanded the first Thunderbolt Sherman to see action. Coleman, one of only 12 female tank commanders in the European theater, had earned her position through extraordinary courage during the breakout from Normandy, where she had destroyed 4 German tanks while commanding a standard M4A1. The new gun was like trading a baseball bat for a sniper rifle, Coleman later wrote in her memoir. Everything about it was precise, calculated, deadly. The computer told you exactly where to aim, the rangefinder told you exactly how far, and the gun put the round exactly where you pointed it. It was like having a crystal ball that showed you how to kill Germans. The first combat test occurred on September 3, 1944, near the Belgian village of Mons. Coleman's platoon, consisting of 4 Thunderbolt Shermans, encountered 7 Panzer IV Ausf H tanks from the 9th Panzer Division moving through open farmland at approximately 1,400 meters, well beyond the effective range of standard Sherman guns. Using the T-13E1 fire control system, Coleman achieved target lock on the lead Panzer IV and fired at 1,387 meters range. The tungsten carbide penetrator struck the German tank's turret front, penetrated completely, and detonated the ammunition storage. The explosion destroyed the tank instantly and killed the entire crew. The engagement lasted 14 minutes. 4 Thunderbolt Shermans destroyed all 7 German tanks without sustaining damage or receiving effective return fire. German crews never achieved accurate range estimation to Coleman's position, and their return fire consistently fell short by 200 to 300 meters. The German survivors, interrogated after capture, reported engagement by American heavy tanks firing armor-piercing rockets at impossible distances. Wehrmacht intelligence initially classified the encounter as involving misidentified M36 tank destroyers, not recognizing that they had encountered the future of American tank warfare. Similar encounters multiplied throughout September as additional Thunderbolt Shermans reached combat units. Near Aachen, 2 Thunderbolt tanks commanded by Sergeants Helen Martinez and Patricia Wong destroyed 11 German vehicles, including 3 Panthers and a Tiger I, without taking return fire. The precision of American gunnery astounded German survivors, who described impossible accuracy and supernatural range. German confusion and failed countermeasures. German response to these encounters revealed complete tactical confusion about the nature of the threat they faced. Initial intelligence reports described encounters with new American heavy tanks, Sherman variants with abnormally powerful guns, or disguised tank destroyers operating in close support of Sherman formations. Some Wehrmacht analysts theorized that Americans had somehow acquired and reverse-engineered German weapons technology. Others suggested that the encounters involved standard Shermans firing experimental ammunition developed by captured German scientists. The possibility that Americans had independently developed superior tank technology seemed inconceivable to German engineering pride. Major Ingrid Kellner, promoted to command the 21st Panzer Regiment after her predecessor's death in the Hürtgen Forest, attempted to develop tactical solutions to these mysterious American tanks. Her first approach involved engaging these super Shermans at maximum possible range, hoping to exploit the superior ballistic performance of German guns at extended distances. On September 25th, Kellner positioned 6 Panthers in hold-down positions overlooking the Rohr River Valley, with clear fields of fire extending beyond 2,000 meters. When 4 American Shermans approached across the valley floor, Kellner ordered her crews to engage at maximum range using high-explosive shells to mark impacts and adjust fire.
October 15, 1944. The secret that had begun with 18 experimental tanks was about to explode across the Western Front.
What German commanders had dismissed as isolated encounters with modified Shermans was revealed as a systematic technological revolution that would reshape armored warfare forever. By November 1944, American factories had produced over 400 Thunderbolt Shermans, distributed across 12 armored divisions. The impact was immediate and devastating. German panzer formations that had dominated European battlefields since 1939 suddenly found themselves helpless against an enemy they couldn't see coming and couldn't fight effectively. Major Ingrid Kellner's 21st Panzer Regiment exemplified the crisis. In 6 weeks of combat, her remaining Panthers had engaged Thunderbolt Sherman 17 times. The results were catastrophic. 14 Panthers destroyed, 0 American tanks lost to her regiment's fire. German crews who had survived Stalingrad and Kursk were being systematically eliminated by American tankers with months, not years of experience. The psychological collapse spread faster than the physical destruction. Veteran German tank commanders like Oberst Werner Hoffmann began refusing direct engagement orders. "We are not retreating from cowardice," Hoffmann radioed to his divisional headquarters. "We are refusing to participate in suicide missions against an enemy that possesses supernatural abilities." Staff Sergeant Dorothy Coleman's crew represented the human face of American technological supremacy. In 3 months of combat, Coleman's Thunderbolt Sherman destroyed 27 German vehicles without sustaining meaningful damage. Her gunner, Corporal Maria Santos, achieved a 91% first-shot hit rate at ranges exceeding 1,200 meters. "It wasn't about being better soldiers," Santos later recalled. "The machine made us superhuman. The computer told us everything: range, lead angle, ammunition selection. All we had to do was pull the trigger when the reticle turned green. It was like having God's own artillery piece disguised as a regular Sherman." German crews faced the opposite reality. Hauptmann Klaus Fischer, commanding a Panther company, described the psychological horror. "You see a Sherman at 1,500 meters, safe range, you think. Then your comrade's tank explodes beside you. No muzzle flash, no sound of incoming rounds, just sudden death from an invisible enemy. How do you fight something you cannot understand?" The numbers revealed the scale of German catastrophe. In November 1944 alone, Thunderbolt Shermans destroyed 312 German tanks, while losing only 8 vehicles to all causes, including mechanical breakdown, artillery, and aircraft attacks. The kill ratio exceeded 39-1, compared to roughly 1.2-1 for standard Sherman variants. Production figures told an even more devastating story. German factories, hampered by bombing and material shortages, produced approximately 40 new tanks per month. American industry delivered 200 Thunderbolt Shermans monthly while maintaining production of standard variants. The industrial mathematics guaranteed German defeat. Dr. Elizabeth Hoffmann's technical analysis confirmed German technological obsolescence. "Our technological obsolescence is 5 to 10 years behind our current capabilities. Their fire control systems represent advancement of 8 to 10 years beyond our current capabilities. Their tungsten ammunition achieves penetration values we cannot match with our heaviest guns. We are fighting 1952 technology with 1942 weapons." Desperate final measures. The Wehrmacht attempted increasingly desperate countermeasures. Some units deployed Panzerfaust teams in close support of tanks, hoping infantry could achieve kills that panzer guns could not. Others experimented with extreme-range engagement tactics, firing from positions over 3,000 meters distant. All approaches failed. Thunderbolt Sherman's advanced optics detected German positions with remarkable efficiency, while their fire control systems remained effective at any range where targets were visible. German tactical manuals, refined through years of successful combat, became obsolete overnight. Colonel Sarah Morrison's team had anticipated German desperation. Advanced Thunderbolt variants, designated M4A3E8A1, featured improved armor and enhanced fire control systems. By December 1944, these Super Thunderbolts were achieving first-shot kills at ranges exceeding 2,200 meters, beyond the effective range of any German tank gun. The hidden legacy. The Battle of the Bulge in December 1944 provided the final demonstration of Thunderbolt Sherman's superiority. German forces committed their last armored reserves in a desperate offensive, including their newest Tiger II heavy tanks. Against 67 Thunderbolt Shermans, the German assault achieved nothing. American tanks destroyed 89 German vehicles while losing only 3 tanks to enemy fire. Major Ingrid Kellner, captured after her Panther was destroyed near Bergstein, provided the most eloquent testimony to Thunderbolt effectiveness. "We never understood what we were fighting. They looked like ordinary Shermans, but they killed our finest tanks with precision that seemed impossible. It was not warfare, it was execution." The technological advantage extended beyond individual battles to reshape strategic possibilities. American armored spearheads advanced with unprecedented confidence, knowing they possessed overwhelming superiority against any German tank they might encounter. The liberation of Western Europe accelerated dramatically. Why the story remained hidden? Despite its revolutionary impact, the Thunderbolt Sherman program remained classified for over 20 years. Several factors contributed to this secrecy. First, the technology involved advanced fire control systems that America wanted to protect during the Cold War. Second, the program challenged popular narratives about American industrial quantity over quality approaches to warfare.
Most significantly, the story lacked dramatic visual appeal. Unlike aerial combat or naval battles, tank warfare occurred at distances where camera equipment could rarely capture the action effectively. The precision kills that made Thunderbolt Sherman so effective appeared mundane compared to explosive artillery barrages or aerial bombardments. The crews themselves rarely received recognition proportional to their achievement. Staff Sergeant Dorothy Coleman destroyed more enemy tanks than most celebrated fighter pilots shot down aircraft, yet received only standard combat decorations. The technological nature of her success seemed less heroic than individual courage or tactical brilliance. The revolutionary impact. The Thunderbolt Sherman program revolutionized military thinking about technological warfare. Colonel Morrison's approach, using sophisticated fire control systems to amplify human capability, became the foundation for modern tank design. Every main battle tank developed since 1945 incorporates descendants of the T-13E1 fire control computer. The program also demonstrated American industrial capability to innovate under extreme pressure. From conception to battlefield deployment required only 8 months, a timeline that impressed even German engineers who examined captured equipment after the war. More broadly, the Thunderbolt Sherman proved that technological superiority could overcome numerical disadvantage, tactical experience, and superior individual weapon systems. German Panthers remained formidable tanks. American fire control systems simply made them irrelevant. The final testimony. The most fitting epitaph for German armored warfare came from General Oberst Heinz Guderian, the architect of blitzkrieg tactics, in his post-war interrogation. "We developed the finest tanks in the world.
crewed them with our most experienced veterans, and employed them according to proven tactical doctrine. The Americans defeated us with mathematics and precision engineering. They did not build better tanks, they built smarter tanks. The invisible weapon that destroyed German panzer superiority was not visible armor or dramatic firepower. It was accuracy itself, delivered through technology that transformed average American tankers into marksmen capable of impossible shots. The Sherman variant that made German Panthers retreat changed warfare forever, proving that in modern combat, the side that sees first and shoots most accurately wins, regardless of traditional measures of military power. The 670 German tanks destroyed by Thunderbolt Shermans represented more than tactical victories. They marked the end of an era when individual courage and superior engineering could overcome systematic technological advantage. The future of armored warfare would belong to the side that best integrated human skill with mechanical precision, and America had shown the world how that integration would work.